Okay everyone, this is just a test video of how we can maybe do this into the future. This will be a video tutorial on how to do question 29d from the 2017 paper. The reason why I've chosen this question is I'm predicting quite a few people ask how to do this because it has something to do with standard deviations and z-scores, normal distributions. But it has something to do with medians as well, and in fact you'll see later on that it actually has, it's not a normal distribution at all. So anyway, let's just get started straight into it. So we see that all the students in a class of 30 did a test. The marks out of 10 are shown in the dot plot. So first of all, we want to find the median test mark. So remember, to find the median, there's plenty of ways of doing it. One way we can do it is see how many scores there are and add 1, divide by 2 to find the position. So we'll do that first of all. So the position equals 30 plus 1 divided by 2, which equals 15.5. So that means the median is going to be between the 15th and the 16th number. So let's go ahead and count our scores. We can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our 15th score is 4, and our 16th score is 8. So now we need to think of what number is between 4 and 8. You can either do 4 plus 8, which equals 12 divided by 2, equals 6, or just realize that the median is in between the two. So therefore the median equals 6. 1 mark straight away. Now that we've done that, let's go on to the next question. We're told that the mean test mark is 5.4 and the standard deviation of the test marks is 4.2. So we've got the mean is 5.4, standard deviation is 4.22. Using the dot plot, we want to calculate the percentage of the marks which lie within 1 standard deviation of the mean. So this is a tricky question. Essentially what we want to do, if we have 1 standard deviation from the mean, that means we're looking at the z-scores between -1 and 1. Now the reason why it's saying using the dot plot is because if we knew that this was a normal distribution, we could straight away say 68%, right? Because we know with normal distributions between 1 and -1. But just looking at it, this doesn't have a normal distribution. You can tell because it doesn't have the curve in the middle. It actually has 2 bumps on either side and there's almost nothing in the middle. So it's not a standard normal distribution, so we can't just immediately look at that. So what we're going to need to do is we're going to find what the score is 1 standard deviation below the mean and 1 standard deviation above the mean. So we'll do 5.4 minus 4.22, which equals, what's that, 1.18. And we could also do 5.4 plus 4.22, which equals 9.62, I believe. So what we're going to be doing now is we're going to see, well, how many scores lie between those two? So looking back at our scores, well, everything between 1.18, well, that means our scores need to be starting at 2. So we're looking at that one, that one, that one, that one, that one, that one. And going up to 9.62, so that means we can include the 9s as well. So we're looking at these scores here are between those standard deviations. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 scores out of these 30 are between 1 standard deviation of the mean. So we're going to do 13 over 30. And I'm asking what percentage. So 13 over 30 times it by 100. And that equals something like, I think it's 43.3%. I don't have a calculator on me, but I think it's something like that. So now that we have that, we've talked about, we assumed that it was going to be about 68%, but that's because that would assume it's a normal distribution, which it isn't. So lastly, the question is asking, a student states that for any data set, 68% of scores should lie within 1 standard deviation of the mean, but we just saw that wasn't the case. So with reference to the dot plot, Explain why the student statement is not relevant in this context. Well, we kind of just answered this question a couple of minutes ago when I said it's not a normal distribution. Because it's not a normal distribution, that means 68% of the scores wasn't the case. So I guess the answer in this particular case is this is not a normal distribution, therefore cannot assume 68% between one standard deviation from the mean. So essentially what we're saying here is it's asking what's an example of a data set that doesn't have 68% of the scores? Well, we just have one here. I mean, because it's not a normal distribution, therefore not all 68% are going to be between one standard deviation and the mean. And we just found that in part 2 when we found it was 43.3%. Anyway, hopefully this helped. If you get stuck on these parts, if you need to ask any questions, feel free to ask later on, or just re-watch the question again. It should be helpful, and if not, let me know. Thank you.